Somewhere far beyond the reach of our telescopes, past the shimmering veil of visible stars, lie realms so strange, so impossible, they defy every law of reality we know. These are not just galaxies lost in the dark, they are cosmic voids where time halts, light surrenders, and existence itself teeters on the edge of annihilation. What if I told you there are galaxies out there where nothing moves, not because it's still, but because time itself has stopped? Where no ray of light can escape because space has folded in on itself. Galaxies where time and light stop. Out in the darkest reaches of the universe, far beyond the observable boundary of human understanding, lie regions so bizarre, so mind-warping that even the laws of physics, time-tested and universally upheld, begin to shatter like glass under cosmic pressure. These are not ordinary galaxies filled with bustling stars and vibrant nebulae. These are haunted graveyards of the universe where light cannot escape and time itself ceases to tick forward. They are places where the fabric of space collapses under the sheer weight of gravity, forming invisible traps from which not even the fastest thing in the universe, light, can break free. In these regions, entire galaxies have been twisted and frozen in time, their very existence suspended in a cosmic limbo. Imagine an ocean of darkness so thick that even a billion suns could not light it. Imagine a place where, for every star born, none can shine. These are the places where time and light die. But how can this be? How is it possible for entire galaxies to be so warped by gravity, motion, and cosmic forces that time stands still? To understand, we need to start with the engine of such extremes, black holes. Specifically, supermassive black holes that lurk in the heart of almost every galaxy. They are ancient, colossal, and terrifyingly powerful, millions or even billions of times the mass of our sun. In normal galaxies like the Milky Way, the supermassive black hole at the center, Sagittarius A*, acts as a gravitational anchor, shaping the movement of stars around it. But in some galaxies, these black holes are not just massive. They are ferociously active, devouring matter at such a rate that they warp the space and time around them like whirlpools swallowing the ocean. These galaxies often appear dim, almost invisible, because the immense gravity traps all radiation, and with it, any clues to their internal structure. The event horizon. This is the boundary we must understand. It is the ultimate threshold, a point of no return. Once light crosses this invisible line around a black hole, it can never come back. It is as if the black hole consumes not just matter but also the very concept of causality. And as you approach the event horizon, time itself behaves strangely. From the perspective of an outside observer, anything falling toward the black hole appears to slow down, frozen in time, inching ever closer to the edge but never quite falling in. If you were to observe a spaceship falling into a black hole, you'd see it slow, redshift, and eventually freeze, smeared across the event horizon like a hologram. Now extrapolate this effect to an entire galaxy. A galaxy caught in a gravitational embrace so strong that its stars, gas, and even the space around it are gradually dragged into the black hole. This isn't science fiction. This is general relativity in its most extreme form. Some galaxies in the early universe, or perhaps in its dying age, may be so densely packed and overwhelmed by central black holes that they become frozen galaxies, suspended in gravitational prisons. Scientists call this gravitational time dilation, and it's not just theoretical. We have measured time differences between clocks on airplanes and those on Earth. In these strange galaxies, however, this time dilation is not just a fraction of a second. It's potentially infinite. Time stops for everything at the brink of the event horizon. But it gets stranger. In some regions of space, clusters of galaxies collapse together, forming what's called a galactic supercluster. At the center of such structures, gravity can grow so intense that light cannot escape, not because of a single black hole, but because of the collective gravity of billions of stars, black holes, and dark matter. These vast dark zones are gravitational shadows, where light is bent, stretched, and eventually erased. We see them not by what they emit, but by what they hide. These are cosmic holes in the sky, revealed only by their effect on nearby galaxies or through gravitational lensing, where their immense gravity bends background light into arcs and rings. They don't shine, they devour. But what about time? Here's where things break into the philosophical. If no information, no light, no interaction can escape these places, what does it mean to exist there? From our perspective, time inside these regions has stopped. Events don't unfold, they are suspended. Light cannot travel, so neither can causality. The past, present, and future blur into a single unchanging state. It's as if the entire galaxy has become a painting, frozen forever in the moment it crossed the edge. Now let's step deeper into the speculative. Some physicists believe that the centers of certain galaxies could contain primordial black holes, remnants of the Big Bang, older than stars, older than time itself. If these black holes have grown unchecked for billions of years, consuming not just matter but even dark matter and dark energy, they could reach a critical state, a point where their gravitational pull affects the very quantum fabric of reality. In such galaxies, space and time don't just bend, they may rupture, forming true singularities. These are not just dark galaxies. They are unreachable, unknowable. Some call them silent galaxies. Others call them tombs. But in essence, they are mirrors of our own fate because our galaxy, too, will one day fall into a black hole. Perhaps hundreds of billions of years from now, when all the stars have burned out and even atoms decay, the Milky Way will spiral into its central black hole. From the outside, it will appear to freeze. From the inside, time will stretch and vanish. The light from its last stars will never escape, and the galaxy itself will become part of the great darkness, one more whisper in a universe where the only thing louder than silence is gravity. But there is one final mystery, the black hole information paradox. If light and time stop at the edge, where does the information go? Does it vanish? Is it preserved on the surface like a cosmic ledger, encoded in the ripples of space-time? Or does it escape through quantum tunnels we cannot yet detect? The answers remain buried inside the most silent galaxies in the universe. And so, we stare into the darkness, searching not just for light, but for time itself. And perhaps one day we'll find a way to enter these frozen galaxies, not to escape them, but to understand what it truly means for time and light to die. As we continue our descent into the unknown, we must confront an even more profound realization. Time, as we understand it, is not a constant force flowing evenly through the universe. It is not a background rhythm that everything dances to, it is instead a dynamic property of space-time, bending, stretching, and even halting under extreme gravity. Einstein's general theory of relativity taught us that mass and energy curve space-time, and this curvature determines how time flows. Near a massive body like Earth, time slows ever so slightly. Near a neutron star, it ticks at a crawl. But near a black hole, or worse, inside a dense galactic core devoured by countless black holes, time stops. Literally. And if that sounds like science fiction, understand this. We've already proven that time moves slower near massive objects using synchronized atomic clocks aboard satellites. GPS technology would fail without correcting for this time dilation. But imagine that on a galactic scale. Imagine an entire galaxy where billions of stars and black holes interact in such gravitational chaos that the very structure of time dissolves. In these regions, not only light is trapped, but so is cause and effect. In some theories, especially those dealing with rotating black holes known as Kerr black holes, space itself is dragged along with the black hole's spin in a phenomenon called frame dragging. Now imagine that on a galactic scale. Picture a rotating galactic core so massive and fast that it begins dragging time itself into a spiral. Observers nearby would experience bizarre effects, time loops, causality violations, and horizons within horizons. A traveler falling towards such a region wouldn't just be torn apart by gravity, they would lose their connection to time. To the rest of the universe, they'd appear frozen. To themselves, reality would stretch infinitely inwards. In such places, death is not instantaneous, it is prolonged into forever. And what of the light? Photons, the very particles that carry information, can no longer escape. They are stretched by gravity until they redshift into oblivion. A photon struggling to climb out of a gravitational well loses energy until it fades into invisibility. In some galaxies, this effect becomes so pronounced that even radiation can no longer leak out. These galaxies, now invisible to telescopes, might be surrounding us, cosmic ghosts whose only trace is their gravitational fingerprint. This is where dark galaxies enter the picture. Scientists have long theorized the existence of galaxies composed primarily of dark matter, unseen and undetectable by normal light. But a handful of discoveries suggest even stranger possibilities. Dark galaxies so dense and quiet that they emit no visible light at all. They are identified only through their gravitational influence on nearby luminous galaxies. But what if some of these dark galaxies are not just full of dark matter, but have evolved into collapsed systems where time and light have ceased entirely? These galaxies could be ancient survivors of cosmic collisions or runaway black hole activity, leaving behind only gravitational scars on the universe. No light, no sound, no time, only shadow. One of the most mysterious candidates is a phenomenon known as dark flow, a strange and unexplained motion of galaxy clusters all moving in the same direction, possibly toward a region beyond our observable universe. Some scientists believe this motion is being influenced by an enormous structure outside our cosmic horizon, perhaps a supermassive collection of galaxies where time and light no longer operate by our rules. Could it be that these galaxies where time and light stop aren't just isolated oddities, but anchors to something larger? Remnants of a previous universe? Gateways to multiversal realms? Or perhaps tombstones of ancient physics that no longer apply? The possibility of other universes, each with its own laws of time, light, and space, has given rise to the multiverse theory. And if even one of those universes collided with ours long ago, it could have left behind a trail of impossible galaxies frozen in time, smothered in darkness, defiant of every known law. In this way, galaxies where time and light stop may not just be the endpoint of entropy, they may be signs of contact, cosmic bruises from something greater. And in our search for them, we may find not only answers to physics, but hints of things beyond it. There is also the theory of false vacuum decay, a quantum event in which the entire structure of reality could collapse in an instant. If this process has occurred elsewhere in the universe, the effects would move outward at the speed of light, silent, invisible, and fatal. If one such event has already begun and passed through certain regions of the cosmos, it would leave galaxies behind it empty, frozen, and stripped of time itself. We may be seeing these galaxies now dead not because of age, but because the rules of existence were rewritten around them. Yet even in their silence, these galaxies speak to us. Their shadows bend the light of galaxies behind them, creating warped rings of distortion. These Einstein rings and gravitational arcs are the signatures of invisible giants, telling us that somewhere out there, something vast and quiet waits. Something that cannot emit light, that cannot progress in time, that cannot be understood without abandoning the idea that reality is fixed. And what if, in the deepest reaches of these dark galaxies, time itself has reversed? Some physicists have explored the idea of retrocausality, the concept that events could influence the past. Could these galaxies be the interface between forward and backward time? Are they scars of a universe colliding with its own reflection? And if light is frozen, could information still exist in another form, perhaps encoded in gravitational waves or entangled particles? The implications are staggering. For if these galaxies truly exist, and if time and light do stop there, then our very understanding of cause, existence, and consciousness must evolve. Because to enter such a galaxy would be to abandon the rhythm of seconds and minutes. To cross its threshold would be to lose the light, and in doing so, to step into a realm where time waits forever. And what awaits there is not destruction, but understanding. Because perhaps in these quiet, lightless, timeless places, the universe is trying to tell us its final secret, not in words, not in light, but in silence.